Okay, welcome to my class project. So I'm going to quickly go over what the project is asking for. So in this project, our goal is to predict the electrical energy output of combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. And we have a set of 9,568 hourly average ambient environment readings from sensors at the power plant, which we will use in our model. Now, this is my first time using Google AI ML, and so it was a great experience for me. The columns in this right here, what you see right here, the columns in this data consist of hourly average ambient variables. So you have temperatures in the range of 1.81 Celsius to 37.11 Celsius, ambient pressure, relative humidity, exhaust vacuum, and net hourly electrical energy output. And that this is exactly what we're trying to predict. What is the net hourly electrical energy output, and which one of these factors most contributes to us predicting this output? And so obviously the conversation then becomes okay, is this a complicated enough to use a neural engine and do more complicated data sets? And the answer is no. Based on the features that have been given, it doesn't seem like it needs to go through a more rigorous neural network process, and so it's probably best to just do a regression model for this one. So for the problem described in the project, determine what type of machine learning approach is needed and select an appropriate output metric to evaluate performance. And so again, regression would probably be the best because again, this data set is not too complicated. It's not a lot of feature sets, and so therefore we don't want to use something more complicated to run this test. Um, and for this data set, I broke it up into a 80 10 10 kind of set, and that way it would be easier for me to do testing. I've done 4 hours of um, testing on this through Google ML, and I'll probably run a couple more, maybe a 5 hour test and a 6 hour test later, just to kind of see what the outcomes are and if it makes a big difference. Um, but let's get to how I did it. So obviously you can download the data set. Once I've downloaded it, um, I was able to upload it to here. So what I can do is I can show you that once you get in here, you can go to your data sets tab on your left, and then you can hit the create button. It will allow you to upload a CSV file. You can upload it, and then just a couple tricks here though. Once you're creating a set, um, you can do multi-label classification, object detection, segmentation if you're doing images. So I did single label classification. And then obviously I chose my region once I've picked one. So here you just kind of have to click something else and then go back to it for it to kind of pick up where you are. You want to keep all that and then pick your region area. So once I've done that, I retitled my data set. Um, uh, Hold on, give me 1 second. Obviously, it's not image, so we want to go to text and then single label classification, and then you can change your region, data set name, and then you can upload everything here once you hit create. Once you have your data set here, then what you want to do is go to training, and you want to say train new model, and then you'll be able to import in the data sets that you had. So for example, if I'm going to train something, um, I can go ahead and click my area, which is here, Northern Virginia, and then I see my data here is already here. So if I want to create a new model, I can hit train new model. I can click the data set that I've already uploaded, and then your object classification. You want to hit regression. Um, this part is a little tricky. So obviously, I think AutoML makes the most sense custom training, you have to be a little bit more technically focused on this, and I don't have much experience with it. So I did AutoML, and so just click AutoML, click continue, and then you can put a description of what it is that you are looking for. And here, obviously, we are looking for the output, net hourly electrical energy output. This is the target that we're trying to find, PE. And so you can put that description there if it helps you to keep things organized. And then target column, obviously we want to target PE, and then just hit continue. Add features. This is choosing feature store and entity type will generate a table of features that you can join to your AutoML table. We don't really need to do this right now. You can just skip it and continue. For this section, you don't need to change these because, again, this data set doesn't have a lot of classifications. It's just numbers, so numeric is just perfectly fine. And we know that PE is our target, so we'll just hit continue. Pricing, obviously you get $300 for the free membership. And so, for this run, I did a 4-hour run for maximum node hours. And then you just hit start training. And then you can play around with it, do another, 5-hour and then 10-hour and look and see what the differences are in terms of what is most relevant to understanding your outcome. So I'm not going to train this right now, but I'll just hit cancel. You'll get your data set just like this. And then you will click power plant training set. Once you click into it, you'll see that once I've run it, it has succeeded and it gave me the outputs here, right? And then you can see the R squared is 0.963. And so the R squared kind of gives you a relative understanding of the quality of data, and the machine learning can tell you that the quality of data is pretty high, since it's between 0 and 1. And so if you're closer to that 1 area, you can see that the data here is higher of quality in terms of the output and what it's telling you. So again, you'll see the R squared is the square of the Pearson correlation coefficient in observed and predicted values, and ranges from 0 to 1, where a higher value indicates a higher quality model. So you can tell that because it's 0.963, closer to 1, it is a higher quality model, and the output is telling you that right now, AT is of the most important data sets that has the most correlation to giving the output of PE, which is your net hourly electrical energy output. And I believe AT is in relation to the temperature, and so 57.58% is scaled, saying that the temperature had the most to do with the output of PE. And then you have your V, which is your exhaust vacuum, that had the second highest impact and importance to PE, which is your energy output. And so at 27.2%, and then your AP, which is your ambient pressure, and your RH, which is your relative humidity. Okay. You can obviously export this. You can view the data sets if you wanted to, right? And then so you see the distinct values in AP, AT, PE, RH, and V, right? And that is my project. Thank you so much for listening. Have a great day.